Alright, so here we have another problem where we're going to solve this formula for a very specific variable. And we have our variables here. This is a very strange looking letter here. It kind of looks like a W, but it's actually an omega. It's a Greek letter, lowercase omega, equals RMV over 1 minus MR squared. Now we're solving this for the variable V. So in order for us to solve for this, we need to get rid of this denominator first. So I'm going to multiply both sides by 1 minus mr squared. And by doing that, multiplying and dividing by the same thing will cancel each other out. And then we can distribute our omega throughout the parentheses here. So 1 times omega would be an omega minus omega mr squared equals RMV. Now here again we want V alone, so we want to move everything else away from it. And right now R and M are being multiplied to V, so the opposite of that would be to divide both sides by R and M so that they will cancel out. So our final answer looks like minus omega mr squared over Rm will equal V. We've isolated the variable. Everything else is on the other side, so that is complete. Now what about the next one? The next one here looks very complicated just because we've got all these M1s and M2s and all that business, V1s and V2s. The subscripts there, 1 and 2, just differentiate to tell you that this V is a different V than this one. So I'm going to go ahead and write my problem out so that I can work with both sides here. Write it out just a little bit larger. Oops, that's not a plus, that's actually a times V1. Alright, now we're solving this for M1. Right now we have an M1 in the numerator and also in the denominator. Now also I have this times V1 over here. Now when I'm multiplying by V1, whenever we multiply fractions, we just multiply straight across the top and straight across the bottom. So this would be the exact same thing as if I had V1 on top. Now let's get rid of this denominator. We don't want this fractions for us to have to deal with, so let's multiply both sides by M1 plus M2. That way we get rid of the fraction and we don't have to worry about looking at that anymore. Now let's distribute our V2 on the left, so we'll have M1 V2 plus M2 V2 equals 2 M1 V1. Now remember, we're solving this for M sub 1, M1. So I want to get everything that has M1s in it to one side, everything else on the other side. So I've got an M1 over on the right. I'm going to move this term here over to the right to join it. So I'm going to subtract M1 V2 from both sides. That will cancel it out of the left and leave us with M2 V2 equals 2 M1 V1 minus M1 V2. Now, over here on the right, we cannot combine these two terms because they're not alike, but we can factor the M1 out. So I'm going to factor the M1, which will leave us with 2 V1 minus V2. And now to get the M1 alone, we can divide both sides by this factor. So M2 V2 divided by 2 V1 minus V2 will equal M1. And now we have isolated the variable, so we are done.